So today we will start the first unit, and first I will tell you what are the important things that you have to study in the first unit. So in first unit you have total two parts. First part is steam power plant, and in the second part you have the boilers. Okay, so mostly I expect from the first part, I mean from the steam power plant, you will get numericals. Okay, and from the second part, I mean from the boiler, the theoretical questions you will get. So first let me complete this one, because whatever the notes you have in that notes, everything is there related to this boiler. Okay, so total 5 types of boilers you have. Okay, one is water tube boiler, and second one is fire tube boiler. So in water tube boiler, it is 2 types. First one is Babcock, and Wilcock boiler. This is one type of boiler, and the second one is Stirling boiler. Okay, so these are the 2 types of water tube boilers, and similarly we have 3 types of fire tube boiler also. Okay, so in fire tube boilers we have first type is simple vertical boiler, and we have the second type, that is cornice boiler, and we have the third type, that is Lancashire boiler. Okay, and what you have to study? The first thing, you have to study the construction details. Then second part is the working principle. Okay, everything is there in the notes. We just study regarding these 5 types of boiler. It is completely theory parts. The diagram you have to analyze, and you have to learn the working principle of these 5 types of boiler. 2 types of water tube boilers and 3 types of fire tube boiler. Okay, so no need to study anything else from this boiler part. And so now we are going to discuss regarding this steam power plant. Okay, so mostly the steam power plants are based upon the Rankine cycle. Okay, I will not go into the details of this steam power plant. Okay, so I will tell you how to solve the problems related to this Rankine cycle by using the steam table. Okay, so these things now we are going to discuss. So for that, in that case, we have a problem. Here I have written one problem from steam power plant. So as I told you, the steam power plant is based upon Rankine cycle. Okay, so before that, let me quickly tell you what is Rankine cycle, how these cycles are looks like, what are the different components of Rankine cycle. Then we will come to the problem. So for Rankine cycle, I will show you the TS diagram first, and simultaneously I will tell you how to use the steam table. So this is the TS diagram. This is the temperature axis. This is the entropy axis. And here we are going to plot a domain. So let me use this one. So you can see here we have 2 lines. Okay, so this line indicates the vapor phase. So for vapor I am writing V, and this blue color line, this will indicate the liquid phase. Okay, and for liquid, this line indicates liquid phase. Okay, so this means before this line, it is completely in the liquid stage, and after this line, it will be in the vapor stage. In between these 2 domains, we will get a mixture of liquid and vapor. Clear? So first we have to understand these two lines. So this blue color line, it will be indicate the liquid phase. All the whatever the points you will get in this blue line, those will be saturated liquid. And this pink color line, it will indicate the vapor phase, and all the points over this line indicates the saturated vapor. Okay, so before this blue color line, it will be completely in liquid stage. After this pink color line, it will be in vapor stage. And in between these two lines, it will be a mixture of liquid and vapor. Okay, and these two lines will meet at a single point, and this point is known as critical point. Okay, so I will not go in details. What is this critical point? What is there? So just from exam point of view, how to solve the problems, based upon that, I am telling you this thing. Okay, so this is regarding the domain. So now I am going to plot the actual Rankine cycle. So I will draw the temperature versus entropy diagram. Y-axis is temperature, x-axis is entropy. Now let me draw the dome. This is the dome we have. Okay, so now here I will show you. First, I will tell you what are the different components of a Rankine cycle. The first component will be boiler. Okay, so the first component of Rankine cycle will be boiler. So what happens inside the boiler? Inside the boiler, we are supplying heat at constant pressure. Okay, so here we will add heat at constant pressure, and along this temperature versus entropy diagram, the constant pressure line will indicate like this. This line will indicate the constant pressure line. So this line indicates the constant pressure line. So here pressure will be equal to constant. Okay, so this is boiler. Then the second component will be turbine. So in turbine, isentropic expansion of the gas will take place. So the turbine will somewhat looks like this. This part indicates the turbine. Isentropic means you can see in this line, this is vertical line where entropy will remain constant. Isentropic expansion will take place. Now the third point will be condenser. And what happens exactly inside the condenser? We are rejecting heat at constant pressure. Okay. It is just opposite to the boiler. In boiler, we are adding heat at constant pressure, and here in condenser, we are rejecting heat at constant pressure. Here we are rejecting heat, QR. QR indicates heat rejected. And here we are supplying heat, so it will be QS. Okay. So now after that, we'll just join these two lines. This will indicate the fourth point, that is nothing but the pump work. So the fourth one will be pump. Okay, so now we are going to name it. We'll start from here. This is point 1, this will be point 2, this will be point 3, and this will be our point 4. So here from 4 to 1, it will be boiler. So for boiler, it will be from point 4 to point 1. This is turbine. Turbine is from point 1 to point 2. So point 1 to point 2, it is turbine. Condenser from point 2 to point 3. So condenser starts from point 2 and it will complete at point 3. And pump will be from point 3 to point 4. So pump will be point 3 to point 4. This is simple Rankine cycle. Okay. Now here, in the problem, you will get some terms. That is, I will tell you some terms you have to remember how to find it out in the TF diagram. One is saturated liquid. Okay. Second one is saturated vapor. Okay. And one more is superheated vapor. Okay, so like this, some terms you will encounter while solving the problems. Okay. So saturated liquid. one by one I am telling you how to identify which point will be saturated liquid. So saturated liquid means I have told you this line indicates the liquid line. Okay, so all the points, whatever the point will present over this line, okay, all these points indicates saturated liquid. Similarly, second one is saturated vapor. Saturated vapor means you can see over here this line, this pink color line, this is the vapor line. So all the points, whatever the points that will present over this vapor line, these points indicates saturated vapor. And the last one will be superheated vapor. Superheated vapor means of the points which lies beyond this saturated vapor line, those lines are called superheated vapor. Okay, so in this way you have to identify the points. When we will solve some problems, you will get to know about it. Okay, so now this is our temperature versus entropy diagram for Rankine cycle. Now quickly we will come to the problem. I will tell you how to solve the problem by using the steam table. So here in this question, you can see here a steam power plant working on Rankine cycle has boiler and condenser pressure of 60 bar and 0.1 bar respectively. Since it is Rankine cycle, so first I will draw the Rankine cycle over here. So this is the temperature axis. This is entropy axis. Okay, so this is 0.4. Whatever the Rankine cycle I have plotted now, the same thing I am doing over here. And I will tell you, according to the question, how to change this diagram. Okay, so what happens here? It is telling that in the steam power plant working on Rankine cycle, boiler and condenser pressure is 60 bar and 0.1 bar. Which one is boiler? This top part is boiler. Here, what is the pressure? Here, the pressure is 60 bar and condenser pressure is 0.1 bar. So this is the condenser and here the pressure will be 0.1 bar. Okay. Then what it is telling, the steam coming out of the boiler is dry and saturated. Okay, so which one is boiler? So 0.4 to 0.1. Okay, so this part is the boiler. 0.4 to 0.1. This is the boiler. 0.4 is the entrance point of the boiler and 0.1 is the exit point of the boiler. But what is the condition it is mentioning over here? The condition is steam coming out of the boiler is dry and saturated. Okay, but you see what is the exit point of the boiler? This region is called superheated region. This is superheated. Okay, so but what is the demand of the question? In question he is asking steam coming out of the boiler is dry and saturated. Okay, so steam means it is nothing but vapor and saturated means the outlet point of this one should be lie in this line. Okay, so this is not the correct Rankine cycle. So we have to modify this Rankine cycle. How to modify this Rankine cycle? You just see over here. So once again, I am plotting temperature, here entropy, and this is the dome I have. Okay, so obviously 0.4 will be here. For boiler, I will start from here. This is 0.4, and I will go up to this point. Okay, I will go up to this point. I will not go like this. Okay, this thing should not be there. Why? Because the demand of the question is steam coming out of the boiler is dry and saturated. So this point, that is nothing but the exit point of the boiler. It will indicate that the exit of the boiler is dry and saturated. Okay, so this is the entrance point of the boiler, 0.4, and this is the exit point of the boiler, that is 0.1. After that, what happens? After boiler, it will go to the turbine. In turbine, it will isentropic expansion will take place. Isentropic expansion means entropy will remain constant. So 0.1 to 0.2. Here entropy will remain constant. After that, in condenser, it will reject heat at constant pressure. Okay, so this is the condenser. This is 0.3. And after that, just you will combine this line. Okay, so this is the actual TS diagram for the given problem. Okay, you can see the difference between the ideal temperature versus entropy diagram and this diagram. Okay, so here what will happen? The exit point of the boiler is superheated, but in this question they have mentioned that the exit of the boiler is dry and saturated. Okay, so that's why we have removed this point. We came up to this. Okay, we stop at this point because this indicates dry saturated vapor line. Right now we will just write down the given data. Okay, so the given data is boiler pressure is 60 bar. So boiler pressure means P1 equal to P4. It is constant pressure line. So P1 is equal to P4 equal to 60 bar. And the condenser pressure means this one, P2 equal to P3. P2 equal to P3 equal to 0.1 bar. Okay, so these two pressures are given and we have to calculate the thermal efficiency of the plant. Okay, so thermal efficiency of the plant, how to calculate? Thermal efficiency, I will tell you the formula first, then we will solve the problem. Thermal efficiency of the plant is net work done divided by heat supply. Okay, what do you mean by net work done? So the right hand side, this is the turbine part. So here we will get work done by turbine, that is WT. And left hand side here we will get the pump work. So that is WP. So net work done means turbine work minus pump work divided by heat supplied. Okay, so this thermal efficiency is having one more formula, that is net heat supplied, that is net heat interaction divided by heat supplied. Okay, so according to the first law of thermodynamics, you might have known for a cyclic process, net work interaction becomes equal to net heat interaction. Okay, so in this manner, what we get? Net heat interaction is heat supplied minus heat rejected divided by heat supplied. Okay, so like this manner, anything we can use, any formula we can use, but better the standard formula is this one. Okay, it is always recommended that you use this formula to calculate the thermal efficiency. Net work done divided by heat supply. Net work done means turbine work minus pump work divided by heat supply. Now, how to calculate turbine work? So here one by one I will write. Okay, so turbine work WT. Which one is which process indicates the turbine? So process 1 to process 2. This indicates the turbine work. Okay, so net turbine work will be at 0.1, suppose enthalpy is H1, and at 0.2, suppose enthalpy is H2. So net turbine work is H1 minus H2. Similarly, how to calculate the pump work? Okay, so pump work equal to H4 minus H3. H4 minus H3. And we have one more formula to calculate for pump work, that is, okay, so specific volume at 0.3, small v indicates specific volume at 0.3 into pressure difference, P2 minus P1 minus P2. Okay, so by these two formula, we can calculate the pump work. And the last one is heat supplied. How to calculate heat supplied? Where we are supplying heat? We are supplying heat over here. Okay, so heat supplied is this point is 4 to 1. Okay, so heat supplied formula is H1 minus H4. Okay, So by using all these things, we can calculate the efficiency. So what is the only thing which is unknown? So the only thing is this H1, H2, H3, and H4. Okay. So the overall thing is, if we can be able to find out the enthalpy at each and every point of this Rankine cycle, we can be able to solve the problem. Okay. So now our only aim is we have to calculate, we have to find out the enthalpy at each and every point of this Rankine cycle. And how to calculate this enthalpy? Those things we can calculate by using steam table. Okay. So one by one we are going to calculate. So the first thing is H1. Where is that H1? H1 means enthalpy at point 1. Okay. Now you can see where is the point 1. Here our point 1 is at this point. This point indicates dry, saturated, vapor. Already I have told you this line indicates dry, saturated, vapor line. Point 1 is over this dry, saturated line. So we have to find out what is the pressure over here. Here the boiler pressure is 60 bar. We have to find out at 60 bar what is the dry saturated enthalpy. Okay. So for this thing, once we go to the steam table, I will show you the steam table over here. Okay. So this is the content page of the steam table. I have to open the content page. So what is the point 1? Here point 1 is saturated water and steam temperature tables. And point 2 is saturated water and steam pressure tables. Okay. So this point 1 is, we do not require. Our requirement is in between 0.2 to 0.5. Okay. These properties we are going to use to solve the problem. So first one is saturated. Point number 2, you can see saturated water and steam pressure tables, because in the question paper boiler pressure and condenser pressure was given. Okay, so that's why we are going to use the pressure table. Where it is? It is from page number 7 to page number 14. So now we will go to that page. Right? Okay. So here you can see in page number 7, what is the heading? Saturated water and steam pressure tables. Okay, why pressure tables we are following? Because in the question paper, boiler pressure and condenser pressure they have given. Okay, now what is the boiler pressure they have given? 60 bar. So here we will see where is 60 bar. This left side, this indicates the pressure. Okay, this column indicates the pressure, absolute pressure. Okay, so what is the pressure in the question? 60 bar. So we have to find out where is 60. So here it is not there. We will go to the next page. Here also it is not there, 0 point. So similarly here, what is the pressure? Here 1 point something is there. We have to find out 60 bar. So here also it is 2.4 point something like that. So we'll go down. So like this, we will find out where 60 bar pressure is. Okay, so here in this page number 13. So here we can find out, here we have the 60 bar pressure. Can you see it or not? This pressure is given 60 bar. Okay, so here we have find out we have the 60 bar pressure. Okay, now after getting the 60 bar, here different values are there. So what is this one? This one indicates the temperature. Then this indicates VF, means specific volume of the fluid. This indicates VG, specific volume of the vapor. This indicates HF. This indicates HFG. Okay, so different values are there. Which value we have to take from this steam table, that you have to understand. Okay, so now I will tell you from here. Right, so what is our requirement? We have to calculate the value of H1. Okay, so we have to find out H1. Where is H1? H1 means enthalpy at point 1. Okay, and here it is dry saturated vapor. Okay, so in steam table we have seen one value is HF, one value we have seen HFG, and one value we have seen HG. Okay, so HF means in this dry saturated liquid line, in this left color line, whatever the points are there, okay, those indicates this HF. HG, this indicates the right hand side. this dry saturated vapor line is there. All the points which will present over this line, that will be indicated with Hg, and HFG will be in between these two lines. Okay, this region in between these two lines, this region will be indicated with HFG. Now our requirement is we have to calculate H1. So H1 indicates over this vapor line or gas line. Okay, so we have to calculate H1 means we have to calculate Hg. Okay, so from the steam table we have to find out here the pressure is 60 bar. So at 60 bar, what is the value of Hg? That will be indicated by H1. Okay, so here I am writing this one. So here our aim is we have to calculate H1 over here. H1. Okay, so H1 is nothing but Hg at 60 bar pressure. Okay, so from steam table we will see at 60 bar what is the value of Hg. Okay, so now we'll go to the steam table. Okay, so where is 60 bar? Here we can see we have 60 bar. Okay, 60 bar is there. Okay, so for the 60 bar we will see what is the corresponding value of Hg. So here HF, HFG, this line indicates Hg. Okay, this column indicates Hg. So here we will see for 60 bar what is the value of H. You can see here for 60 bar the value of Hg is 2785. Okay, 2785. So this value we are going to note down. Okay, so this value becomes, this is equal to 2785 kilojoules per kg. Okay, so we got the value of H1. Clear? Now the next thing is we have to calculate H2. Okay, so what I told you, what do you mean by HF? HF means in this saturated liquid line here, whatever the points are there, those points will be indicated with HF, F for fluid. In the right hand side line, in this saturated vapor line, whatever the points are there, those points will indicate Hg. Clear? And in between these two lines, whatever the points will be there, those points will be indicated with HFG. Okay, so here at point 2 we have to calculate the enthalpy. Okay, so for this thing, if some point will lies in between these two things, then we have to use this HFG term. So how to calculate this one? So enthalpy at point 2, H2 equal to HF2 plus X2 into HFG2. So like this one formula is there. Once you see your notebook, okay, so like this one formula you will get. Okay, so when to use this formula? If some points will lies in between this saturated liquid and saturated vapor line. Left hand side this is saturated liquid, right hand side this is saturated vapor. If in between these two lines some points will be there, then enthalpy at that point will be calculated by using the formula H equal to HF plus X into HFG. By using this formula, we can calculate the enthalpy at that point. Okay. So similarly here, since this point 2 is locating in between saturated liquid and saturated vapor line, so enthalpy at point 2, that is H2 equal to HF2 plus X2 into HFG2. Okay, so this is at what pressure? Point 2. In point 2, what is the pressure here? 0.2 here, the pressure is condenser pressure, and it is 0.1 bar. Okay, so here these things we have to calculate at 0.1 bar pressure. Means from the data book, we have to find out when the pressure is 0.1 bar, what is the value of HF and what is the value of HFG. Okay, so now we will go to the data book and we will find out where is 0.1 bar. Okay, this is 60 bar, so we will go up. We have to find out where 0.1 bar is there. Okay, so right here you can see, yeah, this one is 0.1 bar. This pressure is 0.1 bar. So for this pressure, we have to identify what is the corresponding HF and HFG value. Okay, so for this pressure, you can see HF value is how much? This one, 191.8. Okay, and HFG value is HFG value is 2584. Sorry, HF value we got 191.8, and HFG, this one is HFG, value is 2392.9. Okay, so we are going to note down this value. Now we will write down this value over here. Okay, so what we got, that implies H2 equal to, what is HF value we got? HF value from data book we got 191.8 plus X2. X2 indicates dryness fraction. This value we don't know for the time being. And HFG2 how much we got? We got 2392.9. So this much we got. But here the problem is we cannot calculate the H2 value. Why? Because this X2, what is this X2? X2 is called dryness fraction. This X2 value is still unknown. We don't know the value of this X2. Now our aim is we have to calculate the value of X2. Once we got the value of X2, then we can calculate the value of H2. Okay, now how to calculate this X2 value, dryness fraction value? For that thing, one formula is there. Okay, we have to see this 0.1 to 0.2. It is entropy is constant, it is vertical line. It is isentropic process. So whatever the entropy is there at 0.1, the same entropy will be there at 0.2. Okay, so you can write S1 equal to S2. Suppose this is equation number 1. Okay, because here this X2 is unknown, we will give it equation number 1. Okay, now and we have seen from 0.1 to 0.2, entropy is constant. It is vertical line. So entropy at 0.1, that is S1 equal to entropy at 0.2, that is S2. Now, what is entropy at 0.1? Okay, entropy at 0.1 means here entropy we have to calculate, we have to see what is the value of Sg, because it is dry saturated vapor. So at 0.1, what is the pressure? 60 bar. At 60 bar pressure, we have to find out what is the value of Sg. Okay, again we'll go to the data book. So over here, we will find out where is 60 bar pressure. So here is 60 bar. Okay, this line is 60 bar pressure. Here we will see what is the value of Sg. So here the value of Sg is, you can see 5.890. Okay, so this thing we will write down. So S1 equal to Sg at 60 bar. Okay, that implies S1 how much we got? 5.890 kilojoules per kg. Now, how to calculate this S2? S2 means entropy at 0.2. And this, since this 0.2 is lying in between saturated vapor and saturated liquid line, So H2, how to calculate? So H2 becomes the same formula we are going to use here. H2 equal to SF2 plus X2 into SFG2. Clear? This is equal to H2 means at 0.2. Here, what is the pressure? Condenser pressure is 0.1 bar. So from steam table, we will find out when pressure is 0.1 bar, what is SF and what is SFG. Okay. Again, we will go to the data steam table. And here we will find out when pressure is 0.1 bar. Okay, so this is 0.1 bar. You can see here, this pressure is 0.1 bar. So here, what is the value of H2 SF? Okay, SF is 0.649 and SFG is 7.502. Okay, so these two value we will write here. So SF2 we got 0.649 plus X2 value still we don't know, and SFG value we got 7.50. Okay, now this value we will substitute here. So what is S1? S1 is 5.890 is equal to H2. In place of H2, this value we will write 0.649 plus X2 into 7.502. Okay. Now, if we will solve this equation, from this equation, we can calculate the value of X2. Okay. Simply, we will solve this one and we will get the value of X2. Okay. So something around 0.78 approx we will get. I don't know the exact answer. If you solve it, X2 value approximately 0.78 it will come. Now once we got this X2 value now we will put in this equation. From this equation we can calculate the value of H2. Okay, so H2 equal to 191.8 plus, in place of X2 we will write 0.78 into 2392.9. Okay, now after calculating this one, if we will calculate this thing, then H2 value we will get 2058.262 kilojoules per kg Kelvin. Okay, so in this way we can calculate the value of H2 as well as the value of H1. Okay, after that the next one is we have to calculate H3. Okay, so H3 you can see is 0.3, it is lying on the saturated liquid line. Okay, so we have to it should be nothing but HF. Where here what is the pressure in this line condenser? Here the pressure is 0.1 bar. So you have to find out at 0.1 bar what is the value of HF. That will be indicated by H3. First we will write it down here. So H3 equal to HF at 0.1 bar pressure. Okay, so at 0.1 bar, okay, so at 0.1 bar, what is the value of HF? We have already calculated, that is 191.8. From data book already we have calculated, which is 191.8 kilojoules per kg Kelvin. Okay, so like in this manner we have calculated the value of H3. Now we will switch over to the next one, the final one, that is the value of H4. Enthalpy at 0.4 we have to calculate. Okay, so for that one, so for pump work I have given you some formula. Okay, we have calculated enthalpy at 0.1, we have done with H2, we have done with H3. Now we will calculate enthalpy at 0.4. So for enthalpy at 0.4, means since this 0.3 to 0.4 pump, so we have to use this formula. H4 minus H3 equal to V3 whole into P minus P. This formula we are going to use. So for pump, so we'll write H4 minus H3 equal to V3 into P1 minus P2. Okay, so this formula we are going to use for the pump. Okay, now what is H4? H4 value we don't know. What is H3? H3 value we already got 191.8 equal to V3. What do you mean by V3? V3 means specific volume at 0.3. Okay, again from data book we will find out at 0.3 what is the pressure. Here the pressure is 0.1 bar. So from data book we will calculate when the pressure is 0.1 bar, what is the specific volume of the fluid. Okay, so once again we will refer to the data book. So here we will find out where is 0.1 bar. So here we have 0. So here we have 0.1 bar. Okay, and you can see here this indicates the specific volume VF. So at 0.1 bar VF is 0.001. Okay, so this value we will write over here. So 0.00100 whole into P1 minus P2. What is P1? P1 is given 60 bar and P2 was given 0.1 bar. But you can see this H3, H4 values are in kilojoules. So this bar also we have to convert into kilojoules. 1 bar is how many kilojoules? 1 bar equal to 100 kilopascal. We have to convert into kilo. Okay, so 60 bar means 60 into 100, that is equal to 6000 kilopascal, and 0.1 bar means 0.1 into 100, that is equal to 10 kilopascal. Okay, we have to convert this thing into kilopascal. So then this value we will put over here. So P1 is 6000 minus P2 is 10. Okay, then simply we will solve this equation. And from this equation, if you will solve it, we will get the value of H4. Okay, so how much it will be once I will do it. Okay, so if we will solve it, we will get 191, approximately same value we will get 191.85 kilojoules per kg. Okay. Now, sorry, it will be 190. Sorry, some mistakes I have done here. It will be around 197.79 kilojoules per kg. Okay, so this is H4. Now we have got H1, H2, H3, and H4. Then we will calculate the thermal efficiency by using the formula WT minus WP divided by QS. Okay, so now thermal efficiency WT minus WP divided by QS, which is equal to what is WT? Okay, all the formulas I have written. WT is H1 minus H2. H1 minus H2 minus what is WP? WP is H4 minus H3. H4 minus H3 whole divided by what is QS? QS is H1 minus H4. H1 minus H4. Now you can see all these values we have already calculated. Okay, H1, H2, H3, H4. This H1 and H4 also. All the values we have already calculated. This is H1. Okay, this is H2. And here we have H3. And here we have H4. Okay, you just put value in this formula and you calculate it. Okay, and you will get efficiency something around 35%. Okay, so like this, the only important thing is by reading the question carefully, you have to plot the temperature versus entropy diagram. And after plotting the temperature versus entropy diagram, from steam table, carefully you have to take the enthalpy values. Okay, you have to identify the two pressure line in the top side. Here the pressure is boiler pressure, which is 60 bar. At the bottom line, here the pressure is condenser pressure, which is 0.1 bar. Okay, so according to these pressure lines, you just take the value from the data book, and after that you just substitute those values in this formula, solve it, and you will get the answers. Okay, so this is one question that I have explained you. Okay, so in your notes, some 3-4 problems are there related to this Rankine cycle, reheat Rankine cycle, regeneration Rankine cycles, like that. Okay, so in all the problems, same concepts we are going to use. There will be simple changes in this TS diagram. Okay, but the concept will remain same. Clear? So once you go through it, have a look on it and try to solve the problem, because definitely one numerical question you will get from this Rankine cycle. Okay, and after that the second part is boiler. So from boiler it is only theoretical one. There is no numericals in this part. Okay, so water tube boiler and fire tube boiler, two types of boilers you have. In water tube boiler we have Babcock and Wilcock boiler and Stirling boiler. Similarly, in fire tube boiler, we have simple vertical boiler, Cornish boiler, and Lancashire boiler. Okay, so like this, 3 types of fire tube boiler and 2 types of water tube boilers are there. It is there in the notes. Okay, you have to study the construction details, the diagram, and the working principle of these 5 types of boiler. Any one type they can ask in the exam. Clear? So after that, one more part is also there, that is boiler mounting. Boiler mountings and accessories. Okay, so this can also be a theoretical question. If time is there, you just have a look on this one also. Everything is there in the notes. I have seen the notes, whatever the notes you have. Okay, so 3 important parts. First one is steam power plant problems. Second most important is boiler. Okay, 5 types of boiler you have. You have to understand the construction and working principle of these 5 types of boiler. And the last one is the boiler mountings and accessories. Okay, you just prepare these things, this much of things from unit 1. That is enough. No need to study anything else. Okay, lots of things are there in the notes, but no need to go for all the parts. You just concentrate on these 3 parts. Problems of steam turbine plant, this working construction of these types of boiler, and this mounting and accessory parts. Okay. So that's all for today. Tomorrow, if possible, we will prepare the one video for unit 2 also. Okay, bye.